The moon you see tonight is built from the wreckage of a dead planet. Its name was Theia, a Mars-sized world that shared Earth's orbit until everything changed. 4.5 billion years ago, their collision created the moon we know. Many scientists think Theia formed at a Lagrange point, peacefully sharing the same orbit as the still molten young Earth. For 60 million years, they circled the sun together. Then, gravitational nudges from other planets destabilized the arrangement. Theia's path shifted onto a collision course. It approached at 4 kilometers per second in a glancing blow, not a head-on smash. Because of that angle, the consequences would reach far beyond simple destruction. Theia was obliterated on impact. Much of both worlds' mantles vaporized instantly and sprayed into orbit as a glowing disk of molten rock. The young Earth gained mass while its spin accelerated to a 5-hour day. Only a fraction of the mixed debris reached orbit, yet it was enough. Some scientists propose the event created a synestia, a vast donut of vaporized rock. Earth and its new satellite both condensed from this shared cloud. The orbiting material coalesced at astonishing speed, in decades to a few thousand years. The newborn moon formed just 25,000 kilometers away, 10 times closer than today. It would have dominated the sky above a magma ocean Earth. This newborn companion was forged from both Theia and Earth. The gray moon above you tonight still carries pieces of that lost planet. Its very existence reshaped our world in ways we are only beginning to understand. How do we know this giant impact really happened? The strongest evidence came home with the Apollo astronauts. Those moon rocks tell a clear story of shared violent origins. The oxygen isotope ratios in Apollo samples match Earth's almost perfectly. The moon also has a tiny iron core, exactly what you would expect from rocky mantle material blasted off both worlds rather than a whole planet. The Earth-Moon system's total angular momentum also matches a large off-center impact. All these clues line up. Theia did not vanish. Its atoms are literally shining down on you every clear night. Our moon does far more than light the night. It stabilizes Earth's axial tilt at 23.5 degrees. Without it, the tilt would wobble wildly, triggering chaotic climate swings that might have prevented complex life from taking hold. Early on, the close moon also drove massive tides that shaped coastlines and tidal pools. Those extreme cycles may have concentrated chemicals that helped jumpstart life. The connection remains debated, but the influence is real. The moon is still receding at nearly 4 centimeters per year. Earth's rotation slows in response, and our days grow longer. The process that began with Theia's death continues 4.5 billion years later. Look up on a clear night. That silvery disk is no random visitor. It is the survivor of the solar system's most consequential collision, a constant reminder that catastrophe can create beauty and stability. Theia never truly disappeared. Its legacy orbits above us, raising the tides, stabilizing our seasons, and lighting our nights. The planet that died gave us the moon that made our world livable. If Theia had never struck Earth, would our planet have stable seasons or even complex life? Comments are open. Make your case.